simplified version, when you look at the end behavior, which is the limit at infinity or at negative infinity. And that would give you the horizontal asymptote. You see the relationship? The limit at infinity tells you the end behavior and also the horizontal asymptote. Quick way. Since you are looking at the limit at infinity, and for the algebraic function, it's going to be very, it's similar to the way that you did in pre-calc, but this is the quick, I would say, quick and dirty way to find the limit at infinity. I emphasize at infinity. That means as x approaches positive or x approaches negative infinity, that means in the long term, what happened to the behavior in the long term? What happens to 4x plus 2? 2 is nothing compared to 4 times x. We call 4x the dominant term. In the long term, 4x is the main term to think about the graph, or the one that has an effect to the function, to the graph. Ignore the lowest term. So this is the dominant term. Same idea for the denominator. What is the dominant term? The one involving x. The constant gonna be nothing compared to like 1,000 or 10 millions of very large quantity. So we look at the dominant term of both top and bottom. Okay, that means we're gonna, after in the parentheses here, I put parentheses because this is my kind of my mental math like on the side just to analyze it. So 4x over 20x is 1 over 5. So now I know eventually this graph will approach 1 over 5. Okay, how do I put them together? I'm finding the limit at infinity of the limit x approaches infinity of 4x plus 2 divided by 20x minus 1. So that is the same as, since this is infinity, right? Infinity. I can treat it this way. I look at the larger term, and that will give me 1 over 5. 1 over 5. Now, I get my HA is the horizontal asymptote. Okay, asymptote. So HA, or the line Y, as you know, limit is the Y value, right? As x approaches certain number. So Y equals 1 over 5 is the horizontal asymptote. And this is the right end behavior, because x approaches infinity. And now the other side, the left side, this is the left side. As x approaches negative side, negative infinity, limit of the same one, 4x plus 2 divided by 20x minus 1 as x approaches negative infinity. In the long term, I'm going to have the same limit value as 4x over 20x as x approaches negative infinity, which give me the same value, 1 over 5, because x and x here, same power, same term, top and bottom, they cancel out. Because if I put negative on the top, I put negative on the bottom as well. They are canceled. Therefore, it returns the same number, 1 over 5. In this case, you have only one horizontal asymptote. So one horizontal. Okay. One horizontal asymptote. And this is the way to find horizontal asymptote using calculus concept. Back to pre-calc. When you work on pre-calc to find the horizontal asymptote, you see the coefficient 4 and coefficient 20. And the x has the same power, leading power 1, 1. That means you divide 4 and 20 to give you 1 over 5 the same way. Okay, so this is the way that you've done a lot in pre-calc. And now we're going to use the limit concept in calculus 1 to find the same thing, which is the horizontal asymptote. Okay. we'll start with the simple one, and I will show, well, later on gonna be example that's not just rational function, it's gonna be something involving radical. That the idea in pre-calc cannot be used, but the way that we analyze at finding the dominant term gonna help you find out. All right, for this one, if you could help me real quick, what is the leading term of the numerator? Oh, okay, someone asked.
X
Okay,
cubed.
hang on, please. Joshua, ask your
Oh,
question.
okay.
Why is y equals 1 over 5? Because y equals 1 over 5 is called the horizontal asymptote, and y is the limit value. Okay? Okay. All right, Joshua, go ahead. Sorry about that.
For the numerator, I said x cubed.
Okay, x cubed, thank you. How about denominator?
2x to the, or yeah, 2x to the 5th.
2x to the 5th, yes, because the rest of them has less power and it will not have the major effect to the graph. We look at the leading term. So when we get this, so what would be the simplified form of the dominant terms? Oh, where did it go? Yeah. Okay. Excuse me. So what would be the simplified form of the dominant term?
Is it 1 over 2x squared?
1
Yep.
over 2x squared. Yes, because x power 3 and power 5. 5 minus 3 becomes 2. Yes, so that's the most simplified term. Okay, thank you. So because we are looking at the end behavior. So this is equivalent to the limit of the simplify of the dominant term. And what should we get as it approaches infinity? The top positive quantity, the bottom always positive, right? Because we have x squared. What do you think when you divide 1 by the very, very large quantity? What happens?
0?
Yes, be 0. Be 0. Thank you. And 0, that is your y value as x approaches positive infinity. So that gives you the horizontal asymptote y equals 0. Okay? In similar way, the limit of f of x, we look at the limit of the leading term 1 over 2x squared as x approaches negative infinity, where the negative sign could be problem sometimes, but this fraction has power 2. This is an even power. So it doesn't matter to put the number as very large quantity in the negative sign, but you square it. Right? You square it. When you square it, that means 1 divided by the positive large quantity. That will give you the same number, 0. Everyone agree? Yes?
Yes.
So both of them, both ends comes to the same value of the y. And another case that we have only one horizontal asymptote, y equals 0. So the right end goes to 0, the left end goes to 0. That is the common horizontal asymptote of the graph. Okay? All right. Another one that related to pre-calc. Okay, leading term of the top.
Negative x cubed.
Negative x cubed. Okay, negative sign, negative x cubed. And how about the denominator?
2x.
2x. And then the simplify would be?
Negative x squared over 2.
X squared over 2. Okay, negative x squared over 2. Thank you. Same thing as we did in part B. Limit x approaches infinity. And we look at the leading term, negative x squared over 2. Remember, the limit is the behavior of the graph, or basically where the y value approaches toward 2. So as x approaches infinity, we have negative sign. We have divided by 2 and the power 2. What would that be? The thing that moving or changing would be the numerator. Denominator doesn't change for this term. As x gets larger and larger, what happens to this quantity? Anyone?
Gets bigger.
Gets bigger. Yes, bigger. We use the notation infinity, right? It gets bigger. It's a positive sign or negative sign. What do you think? Would that be negative infinity or positive infinity? Think about the number. Oh,
Negative.
good. Josh, did you say something?
I said, is it negative?
Yeah, it is negative. Why is negative?
Because in the equation it's negative x squared, so it's so the numerator is negative. So
Yes.
a negative divided by a positive is negative.
Okay, thank you. Yes, it's gonna be negative because you're gonna do as the order of operation. You do the power 2 first, right? Power 2, and then whatever the power 2 gonna multiply by negative sign here. That's why the final result gonna have negative inside. Okay, and similar to the x approaches negative infinity, the limit negative x squared over 2. This time the quantity comes in as negative number, negative large number. Would that be the same as negative infinity or the sign switch?
Sign switch.
And then what would be the final result?
Positive infinity.
Positive infinity. Okay, let's see. It looks like it should be that way, right? So think about again other operations. At the bottom we know it's positive, and we have negative sign as negative sign here. And how about the x squared?
Even if it's minus 100 times minus 100, it'd be minus 10,000. It'd be positive 10,000, but then there's a negative sign, so it's still gonna be negative.
Yes. So it doesn't matter you square the positive quantity or negative quantity. The square, the number that comes out is gonna be positive no matter what. And the negative sign as original sign divided by 2 which is positive inside. So the final result still remain as negative infinity. Okay? So this one last. For this case, it's still not too bad yet, but when we get to the radical version, it's going to be a little bit more that we have to think about. Okay, so for this case, both ends, the left and the right end, they both goes all the way down to negative infinity. If you look at the graph, it could be down that way. Okay, go down, down. So what can we say about the horizontal asymptote? Would there be any horizontal asymptote? Horizontal asymptote is the horizontal line that the graph pushes to.
Y equals 0.
How do you get the number
Excuse
y
me,
equals 0?
Well, the horizontal asymptote?
Yeah.
Yeah, Y equals 0.
For this problem?
Oh, I think, yeah, right, because if they're both negative infinity, they're never going to cross. I don't know if that makes sense. I don't know.
But 0, thank you for sharing that. But 0 is the real number.
Oh.
Infinity and negative infinity are real numbers. They are not real number because we could not name any number to represent it, right? But we just
Right.
know that they are very, very large. So if you come up with either negative or positive value of the limit, they are not real number. So in this case, they are none.
Oh,
No
okay.
horizontal
All right.
asymptote, okay?
All right.